attendees are in listen-only mode.
Greetings and welcome to this joint DCMI ASIS webinar, Implementing Linked Data in Low Resource Conditions, with Johannes Kaiser and Katerina Carroccio. My name is Stuart Sutton, and I'm Managing Director of DCMI. It's my pleasure to introduce today's presenters and the DCMI ASIS webinar series. The webinars in the series are brought to you as a service to the membership of DCMI and ASIS and to guests. The goal of the webinars is to advance both the discourse and the practice of innovative metadata design, implementation, and use. Today's presenters are with the United Nations Food and Agriculture Organization. Johannes is head of the FAO documentation group, and Katerina is an information specialist responsible for the AgriVault concept scheme as well as other activities within the FAO documentation group. You will have an opportunity to ask questions of the presenters at the end of their presentation. I will moderate the Q&A session. Please understand that we may not have time to address every question asked in 1 hour and 15-minute time frame. Now with that, I will turn the webinar over to Johannes and Katerina.
Hi, hello everybody. I'm Katerina Carroccio. As Stuart already introduced me, I've been in FAO for about 9 years, and currently I'm the manager of the AgriVault thesaurus.
And this is Johannes Kaiser, and I'm very happy here to be with two hats on my head. Once as the team leader here of our Agricultural Information Management Standards team in FAO, but then also as member and responsible for strategic partnerships in the Global Open Data for Agricultural and Nutrition Initiative, which is a new initiative in the area of open data for agriculture. And I'm happy to be able to introduce this also in our webinar.
Okay. The goals for today's are the following. We would like to give you a high-level view of what is needed to do linked data. And while doing so, we would like to identify possible bottlenecks that are due to working with little resources. And then, based on our experience, give you some suggestions and hints on how to overcome these bottlenecks. Well, of course, this is a big topic, actually, so we need to make some restrictions. And what we have in mind, our target audience in mind is small to medium-sized institutions. Keeping in mind that this talk is not meant to give you like a technical guide on how to do things specific, like a server administration and the like, but rather to give you sort of a view on help or some suggestion on how to plan your entering the linked open data world. So what type of data are we thinking of? Mainly we think of textual data, the type of data that about everybody's got, like a list of publications or catalogs. There could be even specimens in local museums or even fact sheets about plants, animals, or organizations in collaboration, and so on. So the topics that we are touching on today are, first of all, we would like to make clear what our understanding of what the low resource means, and then talk about open data and linked open data, give you an overview of the data life cycle in this context, and there identify the bottlenecks and our suggestion to overcome them. And we'll give you a practical example of Agris. So there are many ways, in many senses, one could be could experience low resources. To us, perhaps the most important, or one that seriously has to be taken in consideration, is the IT competencies. Usually, the most common situation is that there are few IT people around in our institution. They are over busy with many tasks and duties, but the technology is fast moving, and actually what they learned in school is just is not enough. There is a need for personal update, and then here comes another problem, that the working environment might not encourage this. And even if this is the case, there might be a problem with the language. Other issues that we often come across is the need for some competencies on legal issue. So what type of license should be applied? What is a license and a copyright and so on? What should be, what to do in case of controversies, litigations? Other cultural issues are related to the personal attachment, often to the data. So this is my data, I don't want to share it, and this is a something that happens even without a single organization. Also, there might be differences in how people look at data and at problems, really. So there might be the view of domain specialists who know their domain and they know what the data is about, and they don't want to spend time on things that are extra to their core work. But on the other side, IT people may think that some time spent on linking, standardizing the data is well spent. So, and here there is a possible source of tension. All these issues require some time, some investment in time, and this is also a resource that we are usually short of. Then, of course, there is a software side. We might have outdated operating systems and software because they might cost some money, the licenses, or even it's not because it's not considered a priority in the culture of the institution. Of course, there might be problems or constraints from the hardware, and even other constraints like electricity might be unreliable or occasionally available, or even expensive. The internet connection that is fundamental for this for us maybe is low, or dependent on the weather, depending on the situation. So what to do? Well, let's look at the data. The trend right now, you might be aware of this, but the trend is to pay great attention to data. In this sense, interoperability of data is fundamental. So data that can be reused, processed, produced by somebody in some other application and processed in other applications. To this end, the adoption of standards and open formats is considered crucial, and actually is crucial. And the maximum reusability applies because data is commonly shared over the web. So in this framework, open data sits in this framework. What is open data? Really, in a nutshell, open means open like in other open movements. That means open and free. You can look up the definition and its implication at this website. And in practice, it's open data usually applies to government-generated data, this phrasing. So, for example, publication of census data, public investments, housing, environment, these sort of things. This data can be exposed in various ways, variety of formats, XLS, CSV, XLM, JSON, but even PowerPoint, SDMX.
Yeah, this is interesting that Katharina here now goes on machine-readable also formats. I remember on the G8 summit in April 2013 in Washington, Secretary Vilsack, the Secretary for Agriculture of the United States government, said open data is data that are available and usable without restrictions and machine-readable. This is an interesting definition, because there is a difference between theoretical open, you can get it, and practical open, you can do something with it. Because if you get a bunch of PDF pages, you can't do anything else with them than reading it piece by piece with your own human eyes.
Exactly. And the other side of openness is whether the format, this machine readable formats are proprietary or non-proprietary. You can go for either way, but really the preference is to go for non-proprietary formats. Well, openness, again, most of the data around is open already, more or less. That means that it's up there on a website, you can grab it, but with a little attention to the licenses around. So one thing to keep in mind, I mean, something that it's important is for you to check out whether your countries produce a national policy on data, which is getting more and more common, actually. Who does open data already? A really great number of open data initiatives are out there. This list is by no means exhaustive. There are this both national and regional initiatives, or regional collection of national initiatives as well. So you can see this Africa, from UK, from US, from Latin America, Europe, Australia, India, and so on. And also global and sectoral initiatives, like, for example, GODAN, that Johannes is going to tell us about. But why do people actually go for open data? In our view, these are the main reasons. Well, this is not our own view. The need to increase transparency of governments and institutions is very strong, and open data addresses this need, but also the need to create new business opportunities. And also there is a reason that it's the way to go now. So if you want to be in the world now, in the mainstream, you think of going for open data.
Yeah, and this is a place to introduce you GODAN, Global Open Data for Agriculture and Nutrition, which is a follow-up product of this big summit in April 2013 in Washington, where a group of countries and international organizations as the core group was DFID from the UK, USDA, FAO, the CGIAR. For many of you not from the agricultural area, these acronyms will not say anything, but I would say the main players in the area have come together to launch a bigger initiative about open data. GODAN is young, but and you see where there are a lot of gaps, but also already a lot of partners, and we are especially happy that we are already working and contacting in low resource conditions, where we are talking about in this webinar. This is an example from Burkina Faso of their published open data about social indicators in their country. In the end of October, in Cancun, will be a meeting of the GODAN donor group, and this will be associated to the big OGP meeting, what is the Open Government Partnership, where many governments work together to get some agreements, rules, and policies about government's data that have to be published for the advantage of their own population, but also the advantage of other populations. And this is very important, not only limited to public sector. It is a very important goal that also the private sector, and in the private sector, the agro-industry is contributing. And Syngenta, one of the big agro-industry companies, has made a step in publishing their data, because industry should not only be a consumer of available data, what they surely are and what they surely want. And there are especially young entrepreneurs who are interested that more data are open, but also there is a societal obligation and the societal challenge for the big agro-industry to publish more of their data. Katharina will now bring in this new thing, linked open data.
Linked open data. Again, like any other open movements, we talk about open and free in the two senses. So actually, technically, you could also have linked data without the open in between. But we tend to, at least here in this talk today, what we have in mind is linked open data. When you say linked open data, there is typically no assumption on the type of data or nor on the domain. But there is an assumption about the format of the data, because the format of choice here is RDF, which may be made available in various serializations. So for example, XML, Turtle, and free balls and quads, and so on. These are all possible formats for RDF. The idea is not just the data sets, not putting out data sets as in open data, but putting out data sets that are linked to other data sets, and even more, each individual piece of data or various pieces of data are linked to other pieces of data somewhere else, in other data sets. What the reason to go for linked data? I believe the main reason is to be able to reuse the data published by others and being used by others at the same time. You can also promote business this way. You can, there are already applications made for business based on linked data. And there is also a reason that is same way that your data won't be isolated, no longer stay in isolation. You won't be isolated as well. You won't be left behind the information world. But of course, it's an effort. So our question, your question would be, yes, okay, but it's the game really worth the candle? Well, this is up to you to decide, of course. But here we give you an example. This is a screenshot from Agris, our application. Johannes will be talking about Agris later on in this talk today. And this is an example what you could do when you link your data up. This red circle highlights the pieces of data that we do not entail. We simply access from other sources and that are put together because of the technology behind. So you can see the World Bank, data from the World Bank. In this specific case, actually there are other sources that are also linked. Statistics from the World Bank or a scientific paper from Nature. You can see the bottom articles from Wikipedia, here at Wikipedia, or statistics from the FAO country profile and IFPRI, other resources from FAO and sister organizations. This is an example. There are other examples out on the web, but I think the main idea behind is clear. So, question: should I go for open data or linked data? There is no really. They can be seen as two steps. Two phases along the same line, if you want. So you should decide based on your own situation and your own goals. Rule of thumb is that open data requires less effort. Most of the time, it simply requires packing up your data, put it on the website, and make it available for download by others. And this is good if data will be primarily used by others, or you have no direct interest or immediate interest in linking to other data sets. On the other hand, linked open data may be more complex because of this linking step. But it's good if you want to exploit your own data yourself. That is the Agris example I just mentioned. Or enhance your library or document repository. And then enhance your library or document repository with data produced by others. Now I'll give you a very high-level view on a typical linked data workflow. Here I identified steps in the workflow. The first step is, I call it before the linked data. And the other three, the Conway ones, are really the real link data stuff. Now, what the critical point usually for people that just start doing link data is here in the connection between the before and the LOD phase. So when you go from your original, let's say, data set, what you have right now, and you have some sort of, you should have some sort of conversion to get to an RDF position. So this conversion can be done in, there can be different approaches to conversion, and we'll talk about it later. But what I want to highlight here is the issue for maintenance of the data, which is everybody has. It should always be considered carefully. The maintenance can be done kept in the original format, or could be moved in the RDF Word. Then we have this data should be exposed outside. Here there is a selection of the ways, the options you have right now to expose the linked data, and then of course there is a data consumption phase. So let's start with the data generation. First of all, some remarks on RDF, very basic remarks. To remind you that RDF is really a very simple format. It's really about triples. It's a data format and based on triples. The common terminology is to call the bits of the triple subjects, the ID here, predicate, and object. And this would be the graphical representation of the triple. But then these triples can be serialized in various formats, which I already mentioned. Here, these are the available formats right now. What I want to say is that RDF is simple. The format is very simple, so converting RDF it's not such a, I mean, getting some RDF is not so tricky. But the tricky part, or the important part, is the predicate that you have here, the arrow. Why is this a critical role? Because it's what actually defines your data. So it's important when you want to expose your data without ambiguities. So the recommendation is now, in order to be linkable and used and actually useful, is to use standards or de facto standards to facilitate the reuse of your data. So depending on, I won't go into details here because it depends, what vocabulary to use depends on the actual data that you have. You can use various tools around. I mentioned here the linked open vocabulary. It's a registry of linked vocabularies for RDF with a search interface, and you can get an idea of what's there, what's available, and good for you. And there is also this document from the W3C that also has useful links in this sense. So, conversion from existing format. Again, getting RDF is relatively easy. There are many converters around, and the list is here. What approach can be followed? There are basically two approaches to this. The first option is to do a conversion one at a time. That in practice is a migration. Or you could have like a conversion scheduled regularly. Of course, when the conversion is done regularly for exposing your data data maintenance is not affected, which can be a great advantage or an important advantage depending on your situation, because you won't need to implement new user interfaces, you won't need to train your people, you would be able to save some resources. A simple example of a conversion to get a feeling for what we are talking about. Here it's a dummy table. ID of a book, basically this is a catalog. Book number 1 has an author John D, a title this and this, and subject this and this. It's a dummy table and also a simplified version of what normally you would have. The RDF that you get from a table like this, from row number 1, is something like this. So element 1, that was our ID here, has a title, the preferred art of navigation. This is the author, and this is the subject. And this is just some RDF. Then you could get some linked RDF if, for example, instead of having the navigation here, you use a URI of a resource that is already up, available for, I would say, obvious reasons. I put in this example a URI of an Agris concept, the concept corresponding to navigation. In red, I also highlighted here the subject of all these triples, and I put here a URI. I won't go into details about URIs, but these are also important ingredients of getting linked data. And this is also a very well-known topic, so I won't go into details here. And then here, these are the properties I mentioned. What ensures you to have described your data in an unambiguous way. Here, the vocabularies used are Dublin Core for title, Dublin Core property for title, creator, and subject. And this is already a pretty decent piece of linked RDF, so of linked data. You could go even further and, just as an example, replace or link your creator thing to use a URI of Wikipedia, in this case DBpedia. And you could, once you get the idea, you could get things more complicated depending on your area of interest. So here we are on back on the maintenance side. As I said, if you plan your conversion regularly to keep the maintenance, with the idea that your maintenance of the data will be stay untouched, you should also consider that actually there is an extra step, and the step of linking. So the disadvantage here is that you should plan a strict pipeline of for your data maintenance, and include in the pipeline also this step. If you want to go for the other side, for migration to RDF, you may need a user interface, a graphical user interface, unless you can rely on your IT person or some tech-savvy person who can deal with the data from like a programming interface or so.
The problem with converting your basic data and your workflows into RDF is often that those people who are maintaining the data are uncomfortable with it. They don't know how this looks like, and if you don't deliver them the same interfaces as they always had, they will not be able anymore to do their data management. Then often there are also business processes that are not really completely covered by RDF in data management. So often the only possibility you have is to make regularly RDF outputs, or to make an RDF interface to get the data without touching the data maintenance flow. This is a bit an experience that we have had here.
Indeed, this is really a crucial point that is often underestimated. I will go back to the point that Johannes just emphasized with a suggestion for a possible solution to this, just in a few slides. So, but before going there, I would like to make a, to clarify a little bit what can be linked, because there is some sort of confusion around due to unclear terminology that is often used. So, in our view, what can be you can link to essentially two things: either the vocabularies that are used to describe the data, so the properties in the slides in the picture before, The properties that in our example were the title, there could be title in my database or título in somebody's Spanish speaker database. And the other thing that can be linked is the object of the triple. That you might consider the actual data. So for example, the specific author of your book or item, and link it to the same author, or link it to the information related to the same author somewhere else, for example in Wikipedia. So the confusion that you might experience around is that there are often they are often called vocabularies, and this might be unclear also when you go and look up for tools for your needs. When it goes to linking vocabularies, you will realize that this is a really still active research area. And one important example is the Ontology Alignment Evaluation Initiative, which is a benchmark of different systems and algorithms that people are devising and inventing to align vocabularies and ontology. Here again, a terminological note is needed, I believe, because ontology is often used as a generic term, which in practice is used to mean a wide range of things, from simple vocabularies to really complex ontologies with logic statements and so on. And they may also include individuals, like country names or even people sometimes. So our suggestion here is, if you are little on resource, and try to get it right from the start. So look for the standard vocabularies to use for properties to describe your data from the beginning, to avoid getting into linking this specific part. So that means be careful of your design time. As I said, the other things that can be linked are the individuals. This is a relatively simple problem. There's the name of the author in my database and the name of the author in a different database. But still, there are a few out-of-the-box tools. Why? Because usually the problem is the data is, so to speak, dirty. That means a different name spelling are used, or different abbreviations, or even different orders, surname first, second, or given name, or the other way around, and so on. So you can devise your, you might need to devise your own program. This is really usually not that expensive, but it's a good idea to save on resources to prioritize on what you want to link, and do, like, for example, link to one data set at a time. The process of linking can also be manual. If you already know the resources you want to link to, you can pick up one specific URI, so one specific piece of data you want to link, and make the statement somewhere. And this is really, in this case, it's really simple. The other way, which is maybe convenient if in case of big data sets, is to devise an automatic procedure that gives you some candidate links and then do a manual check. The problem here, it's more a managerial problem, but more than a practical problem, is that the data validation usually stays outside of the data lifecycle. It's not really a practical problem in my view, because we have seen that experienced people, like people who know the data, are very quick at validating links. But again, since it's done outside the rest of the tool and the lifecycle, it will require some processing to get the data then inside your repository. Now I'd like to give you a hint. Like the assumption in our view, the assumption what we notice is that everybody has a some sort of catalog of publications, events, and so on. One way to save time and money is to go for Drupal. Drupal is a content management system that allows you to import data from CSV, XML, and RSSP. SQL is not mentioned here. If you have SQL, you will have to convert to CSV, for example, first. But then it will create the RDF for you, and then you would be able to maintain the data with a graphical user interface, which will be probably a different interface from what your people were used to, but still graphical, with no need to interact with complex or with interfaces that might be perceived more complex. And it will also allow you to expose the RDF in some ways. So this is good in case your data is catalogs of documents, people, or something similar. There is no need to be a programmer, really. You won't need to have a programmer dedicated to this, but then some knowledge of Drupal to organize the steps of the translations of the procedure are needed. There are also similar tools that have the same approach. I want to mention here Agris Drupal because it's Drupal but customized for small institutions, and it already includes a tool that allows you to tag your repository, your blogs, documents, or any other piece of other items that you may have, to automatically tag it with Agris, which is already a linked resource, so you would be pretty quickly in the linked data world. And another option could be Scratchpad if your data is more on biodiversity, like you have a museum, you have a catalog from a museum or something like that. Our own experience is with Agris. I won't go in detail here, but this is something that we can discuss pros and cons in depth if needed, also in other contexts. And this applies, our experience applies in case you have, you want to bring up to the level of linked data a controlled vocabulary, a thesaurus. In short, the steps to be taken here are a conversion of the thesaurus into a SCOS concept scheme, and then we suggest to use Workbench for the data maintenance. It will also allow you to maintain the links, and Scosmos for the data visualization and search. Something that you will need is to think of a way to store your RDF. There are very many triple stores around. If you here in this page, you have a list of benchmarks for triple stores, but you can also simply go for the best known ones like Sesame, Allegrograph, and so on. Here, the bottleneck might be on the server side and the IT competences, because you will need to have somebody able to choose for the solution that best suits your needs. And then getting to the exposure of the data. At this point in time, we have these four main options. You can provide a dump of the data for download. You can expose a de-referenceable URIS. You can have a SPARQL endpoint that people can query or applications can query, and you can expose web services. A little bit of pros and cons of each option. The good thing about having a dump is that you'll simply need to download, to create a file, put it up on the server, and then people will download it, and that's it. It's actually good for data consumers in many cases, because they will have under control the access, and the consumption of the data will be under control, which in practice means it will be faster, more efficient. The cons is that if your data is updated very often, it might be hard to keep the dump in sync. It might require some time, a few hours or days, to repeat the pipeline that will bring you to have a file for a dump or for download. You will need to decide a policy on versioning, which is not necessarily a con, actually. And you also will have to decide on what to include in the dump. For example, only the data, also the links, what type of metadata, and so on. Again, not necessarily a con. Actually, this is something very good to decide in any case. Setting up URIs that are differentiable. This is a mechanism that is called okay. You will have a URIs data negotiation. You will have a URIs put up on the web, available for everybody, and there will be
made human understandable.
Yes, it will be the server will decide whether to return HTML or RDF version. So HTML will be for human to look up, and RDF for machines to consume. The advantage of this approach is that your data will be always up to date. So little care to pay in this sense. Content, you would be able to be accessed by applications that need to data up to date. And the other pro is that there are already simple backends available that allow you to have a nicer visualization of the HTML. I mentioned LOD because we have personal experience with this too. The disadvantage is that you have to set up the content negotiation mechanism on the server. It's not a big issue really, but the server must be also up and running all the time. And data in this way is not directly searchable, so it will be only display one piece of data at a time. We can also have a SPARQL endpoint, which is something that is a solution very often advertised, so to speak, but it also have disadvantage. The advantage is that really there is not much work involved on your side, because typically the endpoint is provided by your triple store. So your system administrator won't be really loaded with much burden in this sense. But your server will need to be up and running all the time, and there might be problems on the ability of the server to answer queries. So basically having a SPARQL endpoint means that user can ask run just about any queries against your database. So in case of big queries, like give me the entire data set, this may be very heavy on your server. There are solutions, new solutions under study to overcome this problem. I mentioned here this linked data fragments is an approach that's being proposed and already implemented actually last year. And the idea being of selecting that you select your fragment or linked data for exposure, and so minimizing the load on your server and giving more weight on the client as well. Web service. This is a more traditional technology. The advantage is really it's a known technology in general that has good performances. Of course, that depends on the implementation. A big advantage is that you have a control on your data. So you decide what data to expose, and so you put less strain on your server. The thing is that it could also be built on top of a SPARQL endpoint, or rather on your RDF store. So this could be, in some cases, this could be the way to go to be linked data, but still accommodating other needs, let's say more traditional needs, if you want. The disadvantage is that you will have to implement your services.
I just only a glimpse on the problem of multilinguality. What you have strongly if you go for open data, also because not everyone might understand your data. This is a distribution of content languages for websites as it is reality. You see there is the huge majorities in English, and this does not correspond to the distribution of languages among people, what they are speaking really. And so there is it's a problem of searching, of categorizing, and obviously at the end of reading. Regarding the exposure of your data and the possibility to categorize and search them, the use of open data vocabularies can help you. If you see here this example from AgriVoc, we have, I don't know, how many languages do we have in AgriVoc?
23.
23. So you have 23 languages, and if you use an AgriVoc concept like this for rice, it can easily resolve by machines into these 23 languages, what gives you at least a bit of advantage in making your data accessible for people who speak different languages.
So then we come in practice. The practical question. I'm an institution. I have limited resources, and I want to move to linked data. So what should we do? In our view, you have at least two options. Well, first of all, you need to identify what your exact bottlenecks are. What's the meaning of low resource in your case exactly? And you can decide to address, to compose your data lifecycle according to your constraints. The other approach is to organize a collaboration that would allow you to minimize, in a way, the effort put on the actual production of the data, but then you will have to put some effort in creating partnership and networks. An example of the example that we know best, it's that we work with it every day, of a partnership to overcome resource constraints is Agris. And now Johannes will talk about that.
Yeah, I will I will run now through this example because we are late in time, but you will get it anyway. So, but we want to leave at least some time for questioning. So the Agris network is organized that you have more than 150 partners, but they have a shared data coordination, shared data standards, shared data processing. This is a real picture of the existing Agris centers all over the world. And Agris originates from the 70s and was a big bibliographical database. Now there are about 8 million records, and this is the traditional Agris record. And this is how this traditional Agris record looks today. Looks enormously different because all the elements of the Agris record have been used to link to other sources. So what you see in the upper left part is the original bibliographical record. And here are the related AgriVoc descriptors. Everything else is data that are not directly in Agris, but were open data that were available in other sources and could be linked to this Agris record. I don't go into the details of the Agris data flow. It's simply an implementation of that, what Katharina showed in principle about how to advise data and how to work with data that you get in a non-structured format or in a semi-structured format. Okay. And there is a first thing of low resource conditions. How to contribute to Agris. And one of the experience we have is that people are looking for a cloud solution, for a very simple cloud solution. And we made an Agri-Meta Maker, which has a web interface. And we thought initially only very few people would use this because they would prefer to have their own systems, to set up their own servers. But it's untrue. As this picture shows about the distribution of the metadata tools, the data production tools that Agris providers is using, there is the Agris MetaMaker has come to 22% of our partners, and what shows and says a lot about low resource condition is that Web Agris is nearly 50%. The program, the statistic program here has made an error in giving Web Agris and Web Agris only because of spelling differences. But together, this tool from the 90s, which runs on 486 computers, is still used by many of our partners. But as this tool was adapted to produce de-referenceable data, also this old tool that runs on a computer alone without web connection is able to participate in the Agris data production. The linked data is produced by using the elements of the bibliographical record. And in this case, we are not purists. We are not RDF purists. I think Dan Brickley or some of these RDF persons have said once, oh, at the end, the semantic web is about intelligent linking. And here is an intelligent linking using the title. And this links simply through the Google API to the Google database without any RDF, but it retrieves, in many cases, the full text of a bibliographic resource. Then, obviously, the core of all the linking efforts in Agris are the AgroVoc concepts. Because Agris is 80% at least is indexed or by machines or by human beings with AgroVoc concept that you see here. And behind every AgroVoc concept is an URI. And this URI resolves all these English spellings into the multilingual labels of these different concepts. With this, we can link. Example to Wikipedia. So every Agris record displays the little chapter from Wikipedia, what it's about. We can link to other databases. We link to Data World Bank org. We link to FAO's own statistical databases or to the International Food Policy Research Institute. We link to other articles from the same journal. Or we are using, in this case, alignments between different thesauri, in this case between the Chinese agricultural thesaurus and AgroVoc, to retrieve similar data from the Chinese agricultural science abstract database. Without this, it has to be a repeat for Agris. Without it, has to be export, import. It simply works about semantic alignments of two concept schemes and an agreement of data exchange between two data providers. And in this, with this simple measures, Agris has extended its coverage from the 8 million bibliographical records that are in Agris to, I don't know, more than 50 million or so from the Chinese database. And so this is the outcome. From a relatively banal bibliographical record, you get a rich data page with informations around the topic of your bibliographical record. So this is an example where linked open data technology is used to create richer web pages. The basis for this is AgroVoc, and Katharina has already explained what this means to go through linked open vocabularies. You see here in the scores exact match all the different linkings from AgroVoc that has been established to other vocabularies, and through these linkings, automatically, you see here CAS, this is a Chinese example, automatically other data sets which are indexed with their own vocabularies, but their own vocabularies linked back to AgroVoc can be used. I don't want to say this is the linked open data example. This is only one example how you can, by using open data, this is a most important thing that is open data to exist, and then using linked open data technologies to give a much richer experiences to your users in getting information. Katharina, recap.
A recap of what we've said today, and with our conclusion. So the first conclusion is that you need to understand your own constraints that can be of various nature. We sort of focused on constraints on administration level and pipeline, so the various steps needed. You will have to look for yourself what you need to address first. This is a rapid evolving world, so keep an eye on technical improvements. The SPARQL, the problem of the strain the SPARQL endpoint puts in your server is considered to be something to address, but there's things moving there. For example, data exposure level. Perhaps most importantly, try to be smart from the start. Here, in brief, a recap of our reflection. So start small, one data set only or few. Start relevant, prioritize your data set. Choose the data set you want to get to link data, or the data set you own, and also the data set you want to link to. Criteria, what's central to your application, or what gives you more visibility, and so you can leverage on that for further work. Start from somewhere, reuse experience as much as possible. There are so many initiatives around, try to give you pointers to a few of them, there you can get inspiration. Go in steps, open first and then link. So you might decide to go for simply open data first and then add the links to it. And look for collaboration. Look for collaboration. This is important. In union there is strength. So find your own way of union. That could be organize a consortium to maximize your resource, or simply look for experience and support from other organizations in the same area. Well, I hope that was somehow helpful. Thank you all.
Okay, now we have eaten up 15 minutes of your time to make questions. But we will stay with this slide a bit so you can write down before you get the presentation our email addresses, and we can be punished by having eaten up all this time by you. If you have a question and your question will not be answered in this session here, you write us an email and we promise you we will answer.
Thank you, Johannes and Katharina. We already have a few questions, and you're free to add more questions at the bottom. You'll see a questions input form for those of you that want to also ask. I have a couple of questions regarding Drupal. One of them is Drupal. Doesn't it present its own learning curve and resource challenges? Keeping Drupal up to date, Drupal 7 to Drupal 8, etc. So isn't Drupal an issue for an organization that is already under-resourced, under-resourced in terms of experience, willingness, or technical team, etc., technical infrastructure? Isn't it a problem?
Okay, we answer one by one, no? Otherwise we will forget.
And this, okay, that's fine. Then there's another one. That's one. So isn't Drupal itself, given its challenges and its learning curve, a problem for an under-resourced organization?
Okay, sure. If you compare to do nothing, it has a learning curve and it's a challenge. But if you want to do something and you have things, and you want to organize textual data, then it's the choose of Drupal the easiest thing what you can do, because anything else will make you more headache. It will make you headache. Sure, you have to learn, and as any system also update. But doing it in a different way will be worse. This does not mean that Drupal is a solution for everything. No, it's It's only if you have an example, typically you have a bibliographical data or institutions, data about persons, data, and then there are also already customized solutions. And then maybe you do not want your own Drupal installation. You could go to existing Drupal cloud installation and simply use your piece of it. This is always something to consider, at least not to put IT overhead on your organization.
Thank you. And the second question is, can you tell us if there is a Drupal package or set of modules that work best?
This depends on your problem, what you want to resolve. If you want to set up, an example, a repository, an open data repository for applications, we can tell you, we can help you a Drupal setup. But there are for many things. But as I said, it's not the solution. It's only a proposal of the possible solutions if you want to facilitate your way and you want not start to write C++ or Java.
Okay. Another question. Agris appears to be based on an aggregative model of load ingest, harmonization, and presentation. Can you comment on how federated models are or are not appropriate when contributing members of a load collective are trying to achieve similar goals?
Yeah. Federated models are nice in an ideal world. In an ideal world where connectivity is always quick and 100%, there are no power shortages, never at no point, then you might think that federation, because of you keep all the data decentralized, it could be better. What we are more thinking at the moment is that also decentralized aggregation is something that can be possible. Data sets are maintained decentralized. All Agris partners have their own data sets. They're using them for their purposes. Agris is one of the aggregators which use it for different purposes. It's not the way how this data set lives. This data set lives their own way as distributed, decentralized data sets of organizations. And these organizations, a lot of them do many different things with that. Not all, but a lot of them. So the old difference between federated and centralized, for my thinking, it's overcome, because it's in the area of cloud computing, you simply have to ask a different question. There's a question: how can I resolve a specific problem? And then I do what I want to do for this. And it would be to say some more, but it's good for now.
Another question. The multilingual example, was it specifically to enable searching in other languages, or is it actually translation of resources?
It's both. It depends on where your attention is. It's an effort of translation of resources, but then it's used to allow multilingual search.
Yeah.
In Agris, for example.
Obviously, what you are translating are concepts. You are not translating text, which is a different area of technology and research. But there are some automatic translation systems that are based also on concepts. But in really it is to give multilingual search and categorization, because many people are able to read a specific language. For example, I'm able to read a Spanish text, but I'm not able to search in Spanish. I would never get the correct terminology. I'm able to search in, let's say, in German, Italian, and English, and using multilingual vocabularies, you can search in your language and you retrieve in the language in which the resource is done. Then you know it's relevant. You can try this automatic translation, and if it is very relevant, you go to a translation service.
Okay, another question. Recently, I was making a pitch to my group for a project that would resemble your Agris project from a cultural heritage database and collections, however. The response was, that's just aggregation. Could you please explain, differentiate a linked data effort versus aggregation? Or do you see linked as aggregation?
The architecture of Agris is double. Agris is aggregating only the core. So only the core of bibliographic database is aggregated. All the linked data are not aggregated, but are linked on the fly. So, an example, the GBIS data about biodiversity, or the World Bank data about species, not GBIS data about species distribution, or the World Bank data about population, or the IFPRI data on the global hunger index, or FAO data on countries. Nothing of this is aggregated. This is all linked, and is also linked on the fly. It's using APIs and SPARQL endpoints, and this makes also the particularity it sometimes doesn't work because services are down. So if you want to do playing around with extra services, after a while you will think about aggregation. So a lot of semantic playground that we have in Agris, we could not do with all the linked services, but we can link the services to the Agris backbone. So the aggregation in Agris is, if you took an Agris page, it's not more than 10% of the data.
Thank you. Another question. What tool did you use in the Kenya example to link the open data sources and give close matches?
Yeah, in the Kenya, I think there was a country, I don't know, from DBpedia Kenya or Kenya data from GBIF. What we mostly use in all these examples are AgroVoc concepts, and we use sometimes specific mappings if we have country lists for geographic linkages, and then we have data sources. We do not need specific tools because an open database is, as Secretary Wilczek said, open and machine readable. So they give us or a SPARQL endpoint, like DBpedia, or a specific API, a documented API, as data.bank.org. If they then publish their vocabularies, or if they use some of the vocabularies to which AgroVoc is already mapped, we simply can write 3 lines of code and we can get the data into Agris.
Thank you. I think we have time for maybe 1 or 2 more questions. Do you have ways to assess, understand data access patterns on Agris? I know that terms that are from your original bibliographic records would work easily with analytic tools, but what about the unrelated data that is linked on the right side of your screen? So I'm not quite sure which cell that was referring to. But
I completely understood the question. I have no answer. I'm very interested in doing like this. This is a typical thing where we never have time and money to invest in. We did some analysis on using of, you said of the easy part of the part that we control, but we would need to do some click-through analysis to study user behavior. And what we did is we made a user survey. I forgot now, but we got quite a good response rate if they consider the use of the linked data part of advantage, and we got a 90% yes answer on this.
Okay, one final question. What kind of library system does FAO use? What kind of role does the library system play in generating and manipulating linked data? Is the final OPAC independent of the library system?
I can't answer this question. because we are not the library. Our unit, we had some linkages to the library, but this is long ago, we have the FAO library for us is an Agris center, as any other Agris centers that contributes to Agris in a way that many other Agris centers also do. But we have no specific insight or information about what the FAO library does.
Thank you. Well, I think we have just about used up our time. I want to thank both Katarina and Johannes for today's presentation. Very, very interesting. And I also want to thank all of you who joined us here live on the webinar, and to all of you who will enjoy the recorded session. With that, I think I will turn the session over to Stefan for any final announcements.
I just wanted to add, this was no joke to say that you can send us emails with questions. This is serious, and because we are serious thinking that getting more open data and getting more linked open data is enormous important for our goal in the FAO to improve agriculture and nutrition and for the development goals overall. So this is something what is absolutely in our duties to answer your question when you have that.
And in addition, Johannes and Katarina will have access to any of the unanswered questions that can be specifically answered as well. Stefan.
Hi guys, thank you guys for the presentation today. It was great. To our attendees, I would like you to know that the slides and the recording will be made available to you guys via a follow-up email within 48 hours of today's broadcast.
Okay, well thank you all and have a pleasant day.
Have a pleasant day, guys.
Bye-bye.
Bye.
Thank you.